Oh, it's over there or something. All right, so this is perfect speed and distance as scalars. And then the one thing here, so
Then I'm getting them mixed up.
yeah, so ignorant of ignorant of direction is going to be a scalar described by magnitude alone, and then vector is magnitude and direction. One of the ways I remember that is I write it with an arrow, like the V for vector, and scalar you can do like with the 5, like people write that.
So just changing them?
Just on the second part, yeah, that part, yep, perfect.
So
All right, perfect. And then this is, so you're correct in the explanation here that it would be leaving its original placement, but displacement specifically is how far it is from where it started. So think about this scenario. If I'm standing here and, or like the track,
just basically,
and I walk around the track.
Your displacement is 0.
Yeah, so there is one example where it would happen.
But it doesn't
And
give specific
then
measurements.
this is correct. Yeah, this is correct. So that when your distance would be longer than your displacement. And also there's one more where your distance, the just like the total distance you travel would be more, or your distance is longer than your displacement. Yep.
Would it be this one?
Exactly. Because if we drew a direct line from start to finish, that's how far away you are.
Longer.
Yeah, so the path that you actually go is longer than the direct line. Perfection.
This one I got really confused down here.
Okay, cool. Let's look at that. So what is the distance traveled by the skier during the 3 minutes of recreation? So distance is going to be total amount traveled. So we have from 0, let's see, what are these units at the bottom?
160.
Are those
These are
meters? Okay, it says right here. These are meters.
So this would travel 160 meters?
Well, in the first minute, 160 plus 160 minus 40, which is 120. So it'd be 160 plus 120 plus 120 minus 40, which is 80. So you see how that's the total distance that they ended up traveling?
So 280, then that. So 360?
Yeah, perfect. And I love that you put a question mark there, because that is super helpful for me when I grade to know like that you weren't confident. So I'd rather have you have a wrong answer that you aren't like you're not sure about it, versus a wrong answer where you're like, I know this is the right answer and it's not right, because at least when you are aware. Even better, ask me when you're doing it. What is the net displacement of the skier during the 3 minutes of recreation? So net displacement, net is the same thing as displacement. It just is the total, like, distance you end up from where you started. So he started here.
So
And
160 meters.
where did he end up during the first total 3 minutes?
Right.
So at the end of 3 minutes. Yeah, so he would actually be 120 meters there. And I'm just going to write it in because as I'm explaining it, it's fine. And then displacement during the second minute only, we're looking at started right here at 1 minute and ended right here.
So it would be 40.
Displacement during the second minute. Yeah, I think you're right. Because 120 would be the distance, but displacement should always be measured from wherever you started. Although it says during the second minute, so you could argue that it would be like 160 minus 40, which would be 120 meters.
I had 120 meters there originally.
I saw that. So
It's searching for the displacement, so where you started, so it would be
right, and because it's talking about where you started at 1 minute, then I think that would be correct with
it
the.
was 120.
I saw that. And you had it as negative 120, which is even better. Displacement during the third minute from 2 to 3 minutes, and then same thing. Perfect. Okay, this one.
Might have got them mixed up again.
So this one's correct, And then just this part was mixed up in the same way the other one was. So I'm just going to fix them for you real quick. Vector, magnitude and direction with that arrow, and scalar is just a number. Scalar, speed, vector, velocity, SSVV. So this is how fast, this is the rate, the position changes, whatever.
Largest.
Greatest speed in the same amount of time. True. And then explanation, this is the most distance that they actually end up going.
Does that have a part blank?
No. That's where you answer it. And then this one is correct, that it's true that you can have an average velocity of 0. But the explanation would be the same thing as our previous example, where if your displacement is 0, then your velocity is also 0. So if you end up right where you started, technically velocity is displacement over time, so it would be 0 there too.
I swear this is like following my brother's friend at the grocery store.
Yeah. Lowest average speed. Perfect. So that one's going to have the lowest speed because it takes you the same amount of time and it's the least distance. So if you're walking slower than all your friends, you're going to cover the least amount of distance. And then this one, perfect, lowest average velocity. So you noticed here that they have 0 displacement, which means I would have a 0 velocity. So you did know that here, even though
Makes sense.
Perfect.
Just the wording gets
I know. This one I think I already covered online, so
Might have not looked at it.
that one's correct. I know, but I can still have you look at it. This one, 0 to 3. The distance, the total distance covered is going to be different than the total displacement. And then make sure we have units. So I'm just going to have you look back at that later. And average speed in miles per minute for the 10 minutes of motion. So perfect. Total distance, total time. There we go. Except that 7.6 divided by 10, you're just going to move the decimal once. So it's actually going to be 0.76 instead of 0.076.
That, but
It's all right. I mean, it's already turned in, it's getting graded. So it's just getting marked up. Estimate the maximum speed. So what I first see is the maximum speed 0.4 is less than 0.7. So our average speed can't be, or our maximum speed can't be less than our average speed. So taking a look at that one again, this one we can look at per minute. So in that minute, they travel 0.4. And then here they travel 0.4, but then here they travel 0.5. So that's going to be a faster speed. And then here they travel 0.8, 0.7 plus 0.1. So, and that's in the same amount of time. So that's going to be even faster than our average.
so it'll be 0.8.
Well, I don't know. You're going to have to go back and finish re-examining the rest of those to look for what is the biggest distance traveled, and that would end up being your max speed. And let's see. Greatest average speed for a 10-meter interval. So they're looking at a 10-meter interval, which is covered by these dots, and we're looking for the greatest average speed, which means it's going to be the least amount of time. So you're going to have to figure out, like this is 1 second that passes for 10 meters, and this one is more than 1 second. So this one's faster. And then the same thing there. That's only 0.8 of a second. So that so far is the fastest. This one is 0.7 of a second. So
It just looks like it's decreasing a bit, but also
as long as, well, that one looks, if you look at the slope, that's the other thing to do.
isn't it like slowly increasing that you're talking about with a line?
Yeah, so that's slow, that's fast. So it looks like it gets faster, 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 but then it looks like it gets slower again. So just off my eyes, I would guess this one, which is also the lowest number I found. But I would have you just like double check that. So if it was that one, then you would do 10 meters distance divided by 0.7 seconds, and that would actually give you your speed. And then average speed is going to be total distance, which is, again, all of these are going to be x comma y. 14.2 meters per second. Sounds good to me. Average speed for the overall race. That one you're going to take total distance divided by total time. You don't have to worry about all the little stuff in between. So up here, and if we're not sure which is distance and which is time, it's x comma y. Y is distance.
So 9.84?
100 divided by 9.84. It's just going to be a little bit more than 10.
Yeah, 10.2, I believe, if you round it up.
Yeah,
16.
nice. Meters per second. Boom.